Good morning, everyone. We today we discuss the matrix of elementary transpose element, element, elementary operation या elementary transformation. Today we discuss the elementary operation या elementary transformation. Before starting, you guys to subscribe to my channel. Second thing, make sure you watch this video complete my channel. Share it with friends, your friends, and hit that like button. Look here, before we discuss the elementary operation या elementary transformation. Talk about the matrix, column matrix, transpose matrix, symmetry matrix, skew symmetry matrix, and we discuss the important question for 12th previous video. We have also read about the properties of matrix, commutative law of additive matrix, associative law of additive matrix, existence of identity matrix, and existence of inverse any matrix, and also read about the multiplication of matrix. Here we discuss the elementary operation या elementary transformation of a matrix. Any matrix. Before definition of elementary operation या elementary transformation, we can say definition: any of the following operation is called an elementary transformation. Any of the following operation is called an elementary transformation. First, interchange of two row या two column. Interchange the interchange of two row या column and second, here look, the interchange of any two columns. Second condition, the multiplication of the elements of any row या column by a non-zero numbers. I repeat that the multiplication of the elements of any row या column by a non-zero numbers. And second point, the addition to the elements of any row या column, the corresponding elements of any other corresponding elements of any other row या column multiplied by non-zero number. I repeat again, the addition to the elements of any row या element, the corresponding elements of any other row या column multiplied by non-zero number. And symbol of elementary matrix या row. And elementary transformation is called row transformation या column transformation. Clearly there will be total of 6 operation on the matrix. Here look, symbol to denote different elementary transformation. Symbols to denote different elementary transformation. Number 4, interchange of row या column is denoted by R sufficient I implied by intends to R R sufficient J and Ci intends to Cj, where ith row and jth column. There are 6 symbols to denote different elementary transformation. Here equivalent matrices. Here equivalent matrices. Definition of equivalent matrices. Two matrices A and B. I repeat that two matrices A and B are said to be equivalent if one can be obtained from other by applying a finite number of elementary operation on the other matrix. If A and B are equivalent matrix, so we write A equivalent B. We can write here A equivalent B. And for example of equivalent matrix, here for example let A is equal to 1 2 3 1 3 4 2 0 and applying R1 intends to R2, because here interchange of row first row and second row, then interchange of row, because position of first row and position of second row are interchanging here 1 2 3 and 1 3 4. Then we show interchange second row above and first row down. Then 2 3 8 and 1 2 3 1 2 3 and 2 3 8. Sorry, mistake, put the number because interchange of first row and second row. Then we show here 1 2 3 and 1 2 3 because here we show 1 2 3 1 2 3 and 1 3 4. Then 1 3 4 because interchanging of first row and second row and alag. And next elementary matrix definition of elementary matrix. A matrix obtained from unit matrix. I repeat that a matrix obtained from unit matrix. Unit matrix because second order matrix, third order matrix, fourth order matrix of unit matrix, second order matrix of unit matrix, third order matrix of unit matrix. Means that one, a matrix obtained from unit matrix by a singular matrix operation is an elementary matrix. Because single number, we choose any single number 2 3 and apply in this matrix. Then we get the result. These matrices are called elementary matrix. We can see here I is equal to 1 2 0 1 and I is called elementary matrix of 2 by 2 order because number of row and number of column are same. Then we can see then A is equal to 2 0 0 1 is an elementary matrix because multiply by one row. Multiply this matrix is multiplied by 2 multiply the 2 1 is 2 and 2 0. Then we get the result 0. We can write 2 0 0 1 is an elementary matrix. And next matrix inversible matrix. Next matrix inversible matrix. Tell about the inversible matrix. Here tell about the inverse matrices. Inverse matrices. What is inverse matrices? and find out the A inverse. Definition of inverse matrix. A square matrix. A square matrix, we know that the square matrix is a matrix which has equal number of row and column is called square matrix. We can see a matrix A is equal to Aij because order n cross n, column and row are same, then the matrix is called a square matrix. So I repeat that a square matrix a square matrix A of order n where n is column and n is row, both are same order, is said to be inversible matrix. Said to be inversible matrix if condition if there exists a square matrix B. If there exists a square matrix B of the same order because n cross n order where n is row and column, such that A of B is equal to B of A. We know that A of B is equal to B of A. We can write because the I have read about the multiplication, commutative multiplication. Commutative multiplication, we want to say a product B, the a product B, then we get the result B is equal to A. Let A is equal to 2 and B is equal to 3, then the product of A, dot B is equal to 2 multiple 3 is equal to 6, and again B product A is equal to 3 multiple 2 is equal to 6. Both are same result. Both are same result. The commutative multiplication, hold here. Then product of A dot B is equal to B is equal to IN, where IN is a unit matrix of order n. Let 2 order matrix, 3 order matrix, anybody matrix, then we have to prove the matrix B is called the inverse of matrix A. B is called the inverse of A. B is called the inverse of A and is denoted by A inverse, and and tomorrow we find the A inverse value of A inverse. Any choose the matrix and find out the A inverse in this matrix. In this matrix, and I hope my dear student here to understand tomorrow we very important example to write on the board, and end of the chapter matrix, and new chapter started determinant. So so you guys to uh, subscribe to my channel. uh, Second thing, make you watch this video complete my channel, share it with friends, and hit that like button. Thank you so much. Be careful, you guys to subscribe my channel. Second thing, make you watch this video completely my channel, and share it with friends, and hit that uh, like button. Thank you so for this watching this